Did you know there are particles racing through your body right now, millions of them every single second, and you can't see or feel them? They're called neutrinos. These tiny, mysterious entities are reshaping our understanding of the universe. By the end of this video, you'll see why unraveling their secrets could answer some of the most profound questions in science. Buckle up, because you're about to learn about the most elusive particles in existence. Let's dive in. So, what exactly are neutrinos? Well, they're subatomic particles, even smaller than the protons and neutrons you likely learned about in school. Picture this. Neutrinos are so tiny, they hardly interact with other matter. They pass right through atoms, planets, and even stars. Imagine shooting a bullet through a mountain, only to have it emerge on the other side completely unchanged. That's how neutrinos travel through the universe. But don't be fooled by their small size. They are immensely important. Now, you might be wondering, why have you never heard much about them? It's because neutrinos are the silent ghosts of the particle world. They carry no electric charge, and their mass is almost non-existent. As a result, they don't interact with electromagnetic forces, and this makes them significantly harder to detect. But here's the twist. They're everywhere. Every second, trillions of neutrinos generated in the nuclear reactions of the sun pass through your body. That's right, trillions. But let's rewind a bit. How did we first discover neutrinos? It all began in the 1930s, when physicists studying beta decay noticed something strange. Beta decay is a process where a neutron in an atom breaks apart into a proton and an electron. But something didn't add up. The total energy lost during this decay seemed to be less than expected. It was like someone took a slice of cake from the plate, but there were no crumbs left to explain where it went. Italian physicist Enrico Fermi proposed there might be an invisible particle carrying away the missing energy, and thus the idea of neutrinos was born. For years, scientists believed in them only on paper, but proof came at last in 1956 thanks to experiments by Clyde Cowan and Frederick Reines. They managed to detect neutrinos emitted by a nuclear reactor in an experiment so intricate it was like catching a thread of spiderweb in a hurricane. Their discovery earned them the Nobel Prize, and the invisible became visible, or at least detectable. So, what makes neutrinos so critical to our understanding of the universe? On the surface, they may seem like shy loners, but their behavior carries loads of information about the cosmos. For instance, neutrinos are messengers. They come from extreme cosmic events, like supernovae, massive star explosions that create elements essential for life. Neutrinos are the first to escape these stellar detonations, zipping through the surrounding material long before light does. This allows scientists to study events in real time. Remember the supernova detected in 1987, named SN 1987A? Neutrinos from that explosion reached Earth 3 hours before its light did. It's as if they were the early whistleblowers of the cosmic event, and by studying them, scientists were able to confirm theories about how stars collapse and explode. But neutrinos are not just observers of cataclysms. Here's where things get wild. They might help us unravel the mysteries of the universe itself. Ever wonder why there's more matter than antimatter in the cosmos? Why the universe didn't simply annihilate itself into nothingness shortly after the Big Bang? Neutrinos might hold the key. Researchers are currently studying whether neutrinos and their antimatter counterparts, antineutrinos, behave differently. If they do, it would explain how the universe chose matter over antimatter, allowing galaxies, stars, and even you and me to exist. Here's another twist for you. Neutrinos could potentially shed light on dark matter, that invisible substance that makes up about 27% of the universe. Scientists suspect there might be an undiscovered type of neutrino, nicknamed a sterile neutrino, that could solve the dark matter puzzle. Imagine that. One invisible mystery solving another. Now let's circle back to detection. Since neutrinos hardly interact with matter, how do we even find them? Using detectors that are marvels of human ingenuity. Have you heard of the Ice Cube Neutrino Observatory in Antarctica? It's a telescope, but not like the kind you use to look at the stars. Instead, it's buried deep in the ice, stretching for a cubic kilometer underneath the South Pole. When neutrinos interact with the nuclei in ice, they create tiny flashes of light. By detecting these light flashes, scientists track their paths and study their secrets. It's like trying to catch a single raindrop in the vastness of the ocean, but somehow it works. Neutrino detection isn't limited to Earth. There are ambitious plans to study neutrinos in space as well. Could we one day build neutrino telescopes on the moon or aboard spacecraft? It's an idea that isn't as far-fetched as it sounds. Since neutrinos travel undeterred by most forms of matter, such telescopes could give us an unparalleled view of the universe, free from the distortion caused by Earth's atmosphere. Here's a fun fact. Neutrinos even have a connection to everyday life. Did you know they played a role in nuclear technology? The understanding of neutrino behavior helps in settings like nuclear reactors to monitor and control reactions. Yes, science fiction-style technology is already showing up in real-life applications, and neutrinos are at its core. But the story doesn't end there. In the future, the study of neutrinos could lead to breakthroughs in quantum mechanics and even time travel theories. Time travel? When you consider that neutrinos can travel vast cosmic distances unaffected by time or space, they may hold keys to questions we can't yet fathom. It's thrilling to think there's so much we don't know about these invisible particles. But every experiment, every detector, brings us closer to understanding how the universe truly functions. By now, I hope you see how neutrinos aren't just tiny particles. They're monumental ambassadors of the cosmic story. So, what do you think about neutrinos? Did you know anything about them before watching this? Let us know your thoughts in the comments below. And if you want more awe-inspiring dives into the wonders of space and science, don't forget to subscribe and hit that notification bell. Think about it. Right now, the universe is subtly whispering to us through the silent journeys of neutrinos. And with each passing moment, we get closer to translating that language. Who knows what secrets we'll uncover next? Stay curious and keep looking to the stars. See you in the next episode of Scientific Facts.